Okay, good morning, everybody. Good afternoon to those in Europe. Good evening to those in Asia. I'm going to go ahead and get started. I know that some people are still filtering into the digital room here. On behalf of the Financial Management Association International, I'm very glad to welcome you to the first seminar of the Spring 2026 FEB-RN seminar series. I'm going to keep my remarks short and shoot it over to my colleague Cesario to give you a welcome from FEB-RN.
Thank you very much, Michelle. At FEBRN, we are very excited to start the 13th season of the research seminars in finance, economics, and banking. We had already more than 60 seminars, and is the eighth season, 4 years in a row in partnership with Financial Management Association International. Today, we have a great pleasure to have Professor Lubos Pastor with us. Thank you very much for accepting our invitation. Let me introduce our moderator, my good friend and colleague, Professor Valerio Poti from University College Dublin. Valerio, is now up to you, so I pass to you.
Many thanks, Cesario. It is a great pleasure and honor to have the opportunity to introduce Professor Pastor in this very interesting webinar. Many thanks to my dear friend Cesario for inviting me and for being the driving force behind this wonderful seminar series. And also many thanks to FMA for supporting it. Lubos Pastor is Charles McQuaid, the Distinguished Service Professor of Finance at the University of Chicago Booth School of Business. He's held several prominent positions of intellectual and scientific leadership, both inside and outside of academia. He serves as president of the European Finance Association and board member of the Fama Miller Center for Research in Finance. Outside academia, he serves on the board of directors of Vanguard and the advisory board of the Anderson Institute for Finance and Economics. He has served as president of the Western Finance Association, director of the American Finance Association, director of the Center for Research in Security Prices, board member of the National Bank of Slovakia. And he's had, like I said, several other prominent positions of intellectual and scientific leadership. Professor Pastor's research focuses mostly on financial markets, including asset pricing and market microstructure. That will be the part of his research that I know the most, that I'm most familiar with. Investment management, financial econometrics, and more recently, the economics of sustainability, especially from a financial economics perspective. And I believe this will be broadly the topic of today's webinar, of the paper that he will be presenting on. His articles have appeared in top journals in our discipline, in the American Economic Review, Journal of Finance, Journal of Financial Economics, Journal of Monetary Economics, Journal of Political Economy, Review of Financial Studies, and other important prestigious outlets. So without any further ado, I'll pass the floor to Professor Pastor.
Thank you very much, Valerio. Thank you, Cesario. Thank you all for having me, and thank you all for attending. It's a great pleasure to be here. Let me start sharing my slides. I hope you can see the cover slide. So the title of the paper I'm going to present is Carbon Burden, and this is joint work with Rob Stambo and Luke Taylor. And to motivate what we're doing, the broad question we started with is, how valuable are firms to society? So suppose I ask, how valuable is a given firm to society? The first thing that probably comes to mind is the firm's market value, right? It's the most tangible, the most visible, the most salient value of the firm. It's traded, easily tradable. So people think of market value in general to begin with, but firms create value not only for shareholders, but also for other constituencies, for stakeholders like customers and employees. So if you want to calculate a firm's value to society, you need to add up market value, and let's think of it as shareholder surplus. And then there's consumer surplus, right? So how much consumers get in excess of what they pay for the goods that they purchase. Then there's employee surplus, how much employees earn in wages over the minimum wage, reservation wage at which they'd be willing to work. You have to add up taxes that the firm pays, because those are distributed to the rest of the society. And you should not forget about externalities, both positive and negative, that the firm imposes on society. So the total value of a firm to society is sort of the total of all of these things. And we typically talk only about market value. Today, I'm going to focus on one particular externality, and it happens to be a negative externality. And it's the externality associated with a firm's carbon emissions. Okay, so firms emit carbon and it causes damages, and that's a negative for society. And I want to be clear that this is just one of many externalities that firms impose. So don't think of this as just one thing. Don't think of this as sort of what firms do. It's just one of many things that firms do. And specifically, to measure those carbon emissions, the externality associated with carbon emissions, we propose a new metric which we call carbon burden, hence the title of our paper. And as I'm going to show you in more detail, we define carbon burden as the present value of the social costs associated with the firm's future carbon emissions. So it's a forward-looking measure. We take future carbon emissions, translate them into dollars, and calculate their present value. Okay, so that's a firm's carbon burden. And then what we actually do in the paper, the two main questions we ask is, one, how big is this carbon burden? Okay, and there are sub-questions. We calculate its magnitude in the aggregate, and then at sector level or industry level, as well as at the firm level. Okay, so that's sort of the main thing we do. How big is this carbon burden? And then we also ask, does this carbon burden relate to the cross-section of expected stock returns in any way? Okay. And I can give you a preview of our answers. So our answer to the first question is carbon burden is big, and I'll tell you how big. And second, we find that carbon burden is related to the cross-section of stock returns, and specifically firms that have higher carbon burdens have higher costs of capital. Now, let me be a bit more precise about what we find. So this is a preview of what I'm going to describe in more detail. We find that carbon burden in the US, which is the country we focus on, is actually greater than the total value of corporate equity in the United States. Okay, so it's actually 131%. That's our baseline estimate. 131% of market value of the total of public firms and private firms in the United States. And I had no idea what to expect going in. I think we actually did a little like poll, what do you think this number is going to be? And we were unsure. It could have been 1%, 10%, 100%. We didn't know what it was going to be. So we were surprised by how big this number turned out to be. And we also look at what would happen if the US were to stick to the Paris Agreement goals that the US has been on and off associated with. But I'm not going to talk about that today. You see the preview of our result in that regard. Instead, I want to continue by talking about the magnitude of carbon burden. So in aggregate, carbon burden is greater than the total market capitalization of the US corporate sector. But we also look at the firm level and find that for 13% of firms, which represent about 9 to 10% of total market cap, carbon burden exceeds their market cap based on direct, in other words, scope 1 emissions. Okay. And for 77% of firms, which represent half of total market cap, carbon burden exceeds market cap based on total emissions, which means scope 1 and 2 and 3. Okay, so I'm trying to give you an idea of the cross-section of carbon burdens. We also look at what determines carbon burdens. We run all sorts of regressions, although I'll mostly show you figures today. We find that the amount of emissions, like current emissions, or think of it as last year's emissions, is actually the most important predictor of carbon burden going forward, and including of the wedge between future and current emissions. So specifically, larger emitters today have bigger emission declines predicted for the future. So when you think about which firms are likely to reduce their emissions going forward, it's actually the largest emitters today, which is good news. And the effect is so pronounced that top 30 emitters account for all of the predicted decarbonization of the US corporate sector. And finally, in our asset pricing, in the asset pricing part of our paper, we find that carbon burden is priced in the cross-section of returns. So what we do is run a cross-sectional regression of ex-ante expected stock returns at the firm level on carbon burdens at the firm level, as well as recent carbon emissions. People have run these regressions based on recent carbon emissions, but not based on forward-looking emissions, which is what we're doing in the paper. And we find that carbon burden enters with a positive sign, and it actually drives out recent emissions. So that was an interesting finding that we didn't expect. Okay, so this is a kind of one-slide summary of what we do, and let me dive in. So we define carbon burden as the present value of social costs from future carbon emissions. So I'm repeating what you already saw. And to motivate this, I want to give you an example of two large utility companies in the United States. These are both top 10 emitters in the US, AEP and NextEra Energy. And you're looking at their direct emissions, scope 1 emissions. And this is the past few years of their emissions. So when you look at this, you might say, well, AEP has a larger carbon footprint, and it imposes a bigger externality on society. But actually, if you look at their forward-looking emissions, so these are, and I'll talk in detail about what those are. But if you look at their credibility-adjusted forecasts of their future emissions, you'll see that one of them, AEP, actually has a more credible decarbonization plan, according to MSCI, a leading provider of data, whose data we use. And on this forward-looking basis, it's actually the other company, NextEra Energy, that has a larger carbon burden. Okay? So you see that there can be a difference between the future and the past. And sort of the main emphasis of this paper, the main difference, the main way in which we differ from prior literature is by looking at the future of carbon emissions and not past. Okay, of course, you need forecasts of future emissions, but that is common, right? In finance, we work with forecasts of cash flows all the time. That's how we calculate market values. We take forecasts of future dividends or earnings, and et cetera, et cetera. So that's what we bring in. We bring in forecasts of future emissions, capitalize them, and do some work with them. So that's the contribution of the paper. Let me be more specific. So to compute the carbon burden, we calculate the present value of, well, social costs of future carbon emissions. So there are three components to this present value. C tau is the most straightforward one. This is the forecast of future carbon emissions, C, tau years from now, okay? And then that forecast is multiplied by the social cost of carbon, tau years from now, for which we also need a forecast. And I'll tell you where all of these things come from. And then once I multiply that, I have the dollar damages associated with future carbon emissions. And then I discount them to the present using the discount rate rho. Okay. And for that discount rate, we use three values, which are the three values used by the Environmental Protection Agency in the US in their baseline analysis. So we take 2% as the baseline figure, which, by the way, happens to be very close to the real riskless interest rate in the US at the time of those forecasts. And then we also consider the possibility of a positive, slightly positive or negative carbon risk premium around that 2%. It is not clear what the risk premium associated with carbon forecasts should be. You could make arguments on either side. One could say that states of the world in which we have more carbon than expected are good states of the world, because usually there's more carbon than expected when the economy is stronger than expected. Okay, so in the states of the world where we're going to have more carbon emissions than we thought, more likely than not, the economy will be stronger than expected. So that's good news, lower marginal utility. But on the other hand, it's also conceivable that in states of the world where we will have more carbon emissions in the future, there will be more environmental damage overall. There could be, some tipping point type of events that will damage the economy. So our profession needs to do more work to figure out what the right discount rate is, and we don't have anything to contribute here. So we simply take the discount rates that others have used in the past. And then, because carbon burden is the present value of the stream of future dollars, it's directly comparable to market value, which, as you know, is the present value of future dividends. So we have the present value of future dividends compared to present value of social costs from carbon emissions. We can compare one to the other, and we do that. We also compare carbon burden to other quantities, but market value of equity is our primary focus. And I have one more thing here. I'm going to talk about social cost of carbon on the next slide, but so let me just tell you what it is in words. When I look at the social cost of carbon in, let's say, 2040, and I'm looking at it today in 2026, that social cost of carbon is the dollar cost of social damages resulting from the emission of 1 ton of carbon in 2040 going forward. So imagine 14 years from now, in 2040, 1 ton of carbon goes up. Take the net present value of all of its future damages from 2040 forward. Okay, that's how this quantity is calculated by others. Okay? That's the quantity I'm showing you here. So our forecasts of the social cost of carbon come from the Environmental Protection Agency, actually from US government agencies overall. They had a working group working together. That working group involved more than 100 people, mostly economists, but not only economists, environmental scientists. The group was headed by the EPA. And so these are kind of the latest estimates from the EPA. This is still under the Biden administration, so the numbers might change going forward. But again, it was scientists working on this, and they came up with a 4-module approach to forecasting social costs of carbon. So in their first module, which I think they called something like the socioeconomic module, they projected future population growth and GDP growth, because those are primary determinants of future emissions. So the more population grows, the larger emissions are going to be. And also the stronger the economy, the larger the emissions are going to be, other things equal. So in that first module, they produce forecasts of emissions. Okay? And then they have a so-called climate module where environmental scientists come in and they translate those future emissions into temperature changes and sea level rises and similar quantities. Okay? And then economists come in and translate that into economic damages, and then they discount these damages into the present in the final so-called discounting module. Okay? And you're looking at the outcome of their analysis. So the middle line is the baseline that I'll be using, although I'm going to show you the results based on the other 2 lines as well. You may have seen these numbers mentioned already. If you've ever seen a $200 per ton cost of carbon, that's what these numbers are. Okay, so as of today, the cost of carbon is about $200 per ton, according to these estimates. These numbers are higher than the numbers you see in markets. So Europe has its own markets, and the numbers there are maybe half, maybe a little less than that. So these are the numbers we'll be working with. If you think the social cost of carbon is half of what I'm showing you here, then just divide all of our numbers by 2. And I think carbon burden remains big even if you divide our numbers by 2. I should also comment on why these series are increasing. They're increasing because the idea is that carbon emitted in the future, let's say in 2050, is going to cause more dollar damage for at least a couple of reasons. One is, at that point, by 2050, there will already be more carbon in the atmosphere. And emitting 1 additional ton when there's already more carbon in the atmosphere causes more damage, right? Because damages are convex in the amount of carbon in the atmosphere. So that's one reason why this series is increasing, according to the US government agencies. The other reason is that the economy will be larger in 2050. And, so there will be more damage. There will be more homes damaged by floods and more damage overall because the economy will be bigger. So again, we have no contribution here. This is 100% taken from others. So we are standing on the shoulders of 100 plus people who produce these forecasts. How about the forecasts of emissions? So I'm going to show you, I'm going to work with forecasts at the aggregate level as well as firm level. Let me talk about the aggregate forecasts first. Okay? So those aggregate US forecasts come from, again, from US government agencies, and specifically from the Energy Information Agency and the Environmental Protection Agency. So we pieced together the forecasts of total US emissions, and these are all greenhouse gas emissions. So not just carbon dioxide, but also non-carbon dioxide emissions like methane and nitrous oxide and a few others. So we take their forecasts, and their forecasts end in 2050. And you actually see what's going on. This is the series that you can get from US government agencies. And then because we have a present value kind of going on forever, we had to make an assumption about what happens beyond 2050. And we just applied judgment. So, and specifically what we did is take the cumulative growth over this period between today and 2050, turn it into an annual rate. So there's an annual rate of about -0.5% per year. And then we just extrapolated that rate into the future forever. Okay. Of course, forever doesn't matter all that much in the end, because we are discounting. But this is ad hoc. It's not clear what else we could do here. By the way, you'll notice that we had to make some judgmental calls here. And that's why all of these estimates I'm going to talk about come with a substantial amount of uncertainty. The idea was we tried not to err on one side or the other. We simply tried to do kind of the most natural thing you would want to do without imparting any bias. Okay, but I wanted to mention this caveat about the extrapolation in the future. So those are the aggregate forecasts. So I've told you about the discount rates. The discount rates are 2% is our baseline, plus minus 50 bips for potential carbon risk premium. These are social cost of carbon forecasts, and these are the forecasts of the aggregate carbon emissions. So now I can take these three components, plug them into the present value formula. And here we have our estimate of the total carbon burden for the US. And it's $87 trillion. And that's a pretty big number. You can compare it to various things. Again, because it is a present value, we compare it to the market value of equity. And again, this is total. This is not just stock market equity in the US. This is total public and private equity of all private businesses as well, because it's all companies that make products, et cetera, that contribute to carbon emissions. So it's 131% of that. And that is the number I'm highlighting here, okay? So that number, 131%, corresponds to carbon burden from all future years under the 2% discount rate, which is our baseline discount rate. And you can immediately see the high sensitivity of our estimates to the choice of the discount rate. If you choose a 2.5% discount rate, assuming a 50 basis point premium for risk premium for carbon emissions, carbon burden is only half of what we report. And if you assume 1.5% discount rate, carbon burden is actually twice as large. And there are people who have used discount rates of all kinds. I'd say 2%, we actually talk about this in the paper. There's a survey of professional economists who work in this area. What do you think would be the most sensible discount rate? 2% is the median response that people give. Doesn't mean it's the right number, but it's certainly in the ballpark, and it's actually the median response. We also separate carbon burdens through 2050 from those from all future years. We do that because we had to make the judgmental call about how to extrapolate emission forecasts beyond 2050. So if you don't believe our extrapolation, you should at least believe, you should put more trust into the government's forecasts of carbon, and then look at the number through 2050. So that partial carbon burden, which is cut off at 2050, it's like assuming that we will be net zero beyond 2050, which is not going to happen. But assuming that, carbon burden would be 44% of equity value. So these are the aggregate estimates we have. And as I've mentioned, market cap is only one thing you can compare a carbon burden to. You might say, well, what if I compare carbon burden to the total market value of equity and debt? What if I essentially say that it's not only shareholders, it's the debt holders that are also kind of responsible for this carbon burden? well, then the number falls from 131 to 93%, which is still a large number, at least in my mind. Now, talking about responsibility, I want to be very clear that we do not blame anyone, any company or the corporate sector for these carbon emissions. Responsibility for the carbon burden is inherently shared by companies that produce these emissions, by households that buy the company's products, by governments that set the rules within which these companies operate, and in general by society as a whole. Our society needs to operate. It's pretty cold in Chicago here today. If you check, it's something like -10 Celsius. I am very glad that we are heating this building and producing a lot of carbon emissions in the process. So I'm responsible for this carbon burden. I happily accept that responsibility. So I want to be very clear: we don't blame anybody. It is a burden on society, but it's not just on corporations. Another way to look at carbon burden, by the way, is to compare it not to corporate equity, but to the consumer surplus that US companies produce. We do not quantify that surplus in our paper, but Bruno Pellegrino has a nice paper in the AER in which he does that completely independently of what we do. And if you take his estimates, they are about 9 times larger than our carbon burden. So if you look at it that way, you say, well, US companies produce a lot of carbon emissions, in fact, more than shareholder value. But that carbon burden is still only 11% of the surplus that we consumers get from the same companies. So surely it wouldn't be right to shut down the US corporate sector just because its market value is less than its carbon burden. Because clearly, as I said at the beginning, companies create a lot of value for society, not only for shareholders. This is, in a way, this is perhaps the broadest message I'm trying to get across here, which is that companies matter to society in so many ways that dwarf their value to shareholders. Okay? Which is a relevant message, by the way, because we often talk about things like, take the Friedman doctrine, Milton Friedman doctrine. Companies should focus on maximizing market value. I think that doctrine, you have to think harder about it once you recognize that market value is only a small part of a firm's value to society. There really are so many other things that are much bigger than I thought relative to market value. So anyway, this is just a broad perspective on carbon burden in aggregate. Now let me turn to firm level forecasts of carbon emissions, because we do some work at the firm level. So we take these forecasts from MSCI, a leading provider of data, Morgan Stanley Capital International. They give you they give us data on individual forecasts for firm N T years from now, and they're based on two things. They're based on the firm's own forecasts of carbon emissions. So many firms, not all of them, in fact, 800 of the firms in their sample have their own emission targets, which they have publicly declared. So for those firms, this target value is taken from the company itself. It's the self-declared emission target. But then MSCI doesn't just take the firm's target at its face value. It multiplies it by its own credibility weight. So each company N has its own credibility weight, WN, which reflects how credible these forecasts are according to MSCI. So MSCI chooses these weights, and it chooses them based on things like whether the company has a history of meeting its past targets, or whether the company has short-term targets as opposed to long-term. The idea being that short-term targets are more binding. Also, WN is larger for companies that whose targets are certified by third parties. So MSCI has a well-defined procedure for choosing these credibility weights, and then multiplies them by these targets, companies' own targets. And then the balance of the forecast goes to kind of a baseline assumption, business as usual, which is 1% growth in emissions. And that number comes from historical data. MSCI is very specific about which data set they take it from. Okay. So these are the credibility forecasts, credibility adjusted emission forecasts we're going to be working with at the firm level. And I am skipping a lot of steps and simply summarizing the results. So we find that looking at scope 1 emissions, so direct emissions, for more than half of all firms, 55% of all firms, their carbon burden is less than 5% of their market cap. Okay, so what this means is that for the majority of US companies, carbon burden is tiny relative to market value. It's less than 5% of market value. Okay, and you find the lowest carbon burden to market cap ratios in sectors such as finance. The financial industry is very clean. Healthcare industry is very, very clean. Telecom, obviously, people who work in offices tend to have low carbon footprints. However, for 13% of companies, their carbon burden exceeds their market cap. And the highest ratios of carbon burden to market cap are observed in the utilities and energy sectors. Those are by far the biggest, followed by the chemicals industry. If you look at total emissions, so not just scope 1, but throw in 2 and 3 with all the warts that come with that, we could talk about that. Scope 2 and especially 3, scope 3 emissions are very tricky. But if you do that, then you find that actually for 77% of firms, their carbon burden exceeds their market cap. And by the way, the finance industry becomes one of the most polluting based on that metric. The idea is that if a bank lends money to a company that emits, then the bank gets a share of that company's carbon emissions. And if BlackRock has an index fund that is diversified across all companies, then BlackRock inherits the carbon emissions of all those companies. That's how scope 3 emissions are calculated for financial firms. So not surprisingly, the finance sector goes from the cleanest to one of the dirtiest, actually, just about the dirtiest, based on scope 3. Okay, so this is kind of the overall summary of carbon burdens at the firm level. If you look at the determinants of carbon burdens, we run regressions, which I'm not showing you, but this is probably the main takeaway figure from those regressions, which is that the number one forecaster of future emissions are current emissions. So on the x-axis are current emissions, or think of it as past emissions. These are the emissions over the past year, most recent year. And on the y-axis is the cumulative growth of the firm's emissions between today and 2050. So this is forecast, credibility adjusted forecast-based growth of emissions. And there's a very strong negative relation, regardless of which scope you look at. So basically, the largest emitters today have the largest expected decarbonization going forward. Okay? And that's good news because those are the firms we need to decarbonize. We don't need tech firms to decarbonize because they have no carbon footprints. Anytime I see, Microsoft declaring being net zero or something like that, that's just meaningless. That has nothing to do with what our society needs. Our society needs these big emitters to decarbonize eventually. And that is forecast to happen. And in fact, it's the 30 largest emitters that are doing most of the work. So let me tell you what this means. This is an interesting chart, I think. The solid line at the top shows you aggregate emissions of all 2,441 firms in the MSCI sample that have the corresponding emission numbers. And the vertical line is today. And today being, I thought we were doing it in 2023. This must be a line in 2022. But when you look back, you already see that the U.S. corporate sector has been decarbonizing pretty strongly. And if I were to extend this further back, you would see this very clearly. And this is well known. The United States has been decarbonizing as a whole. Europe has been decarbonizing as a whole. So in the West, emissions have been dropping steadily for well over a decade. In the East, outside the West, emissions have been growing very sharply over the past couple of decades. So that is where all the global growth is. It's not in the West. So in the US, you see this decline in emissions, which is projected to continue going forward. This is based on all firms. It turns out more than half of all emissions in the US are coming from just 30 firms. So take the largest 30 emitters, Exxon, Chevron, the utility companies I showed you, they account for more than half of all emissions, scope 1. And all the future decarbonization is coming from them. Because if you look at the remaining 2,411 firms, there is no decarbonization projected, essentially. Okay, so it's interesting. I didn't realize how heavy the right tail of the distribution was. The last part of my talk is the asset pricing part, and I'm going to keep it brief. So I'm only going to show you one table. But what we do here, I have to tell you what's going to be in the table. So we look at the cross-section of expected stock returns and see if there's any relation to carbon burden. On the left-hand side of our regression, we're going to have an ex-ante measure of expected stock return. And specifically, we're going to work with a measure of the implied cost of capital. So what is that? Many of you are familiar with this concept. This is the discount rate that sets the present value of future earnings forecasts, cash flow forecasts, I should say, equal to the current market value of the company. And this implied cost of capital can be computed in various ways. Mostly people compute based on analyst forecasts of earnings. This paper by Hu, Van Dijk, and Jiang uses regression-based forecast of future earnings, which a subsequent study shows is actually more precise than analyst forecasts of future earnings. So we're using what a recent 2021 paper told us is the best measure of the implied cost of capital for a company. It's going to be the left-hand side variable in our regressions. On the right-hand side, I'm going to put two variables. I'm going to put the firm's carbon burden divided by its market cap. So that's future carbon, okay? And I'm also going to put in last year's carbon emissions converted into dollars divided by market cap, okay? So think of it as past carbon or current carbon, but this is the last year's carbon emissions. And a few prior papers have run these regressions without carbon burden, okay? So people have regressed, like Lasse Pedersen has a nice recent paper. They have regressed the implied cost of capital on C over M, but nobody has regressed things on CB over M because nobody has worked with CB over M. So let me show you what we got. And I'm going to keep it simple, so no quantities, just signs. In the first specification, we regress carbon burden on future carbon, and we find a strong positive and significant relation. So firms with higher carbon burdens today have higher implied cost of capital in the future. So that's consistent with the theory in this area, which suggests that firms that are kind of brown, here we are defining brown based on future carbon, should have higher costs of capital. And that's a good thing in terms of incentivizing firms to become green and putting a higher hurdle on investment projects of these companies. In the second specification, we replicate the regression run by others, where we regress the ICC on past carbon, so on last year's carbon divided by market cap. And again, we find a strong positive and significant relation. Okay, so this is not surprising. The first column is surprising, the second one is not. The third column is the one that I find the most interesting. If you put both of them in the regression, they are relatively highly correlated because firms that are heavy emitters today tend to have high carbon burdens, right? But there's enough of a wedge, enough of kind of differences in forecasted emissions growth that there is no like multicollinearity problem here. You put them in, everything looks perfectly fine when you look at the results. And the interesting thing is that carbon burden retains its significant positive coefficient, whereas past carbon flips the sign to insignificantly negative. Okay. These three regressions are run literally the way I showed you. They're simple regressions without controls. So we are not including controls for beta, which you would want to do. If you have expected return on the left, you'd want to have beta on the right. We are not controlling for size or value, book to market, which are kind of the most popular controls. But when we do add those controls to the regression, which we do in columns 4, 5, and 6, the results remain unchanged. Okay, so the magnitudes change slightly, but the significance remains unchanged. Okay, so this is the bottom line of our asset pricing analysis, which is pretty straightforward but novel. Essentially, future carbon seems to be priced. A natural interpretation here is that market participants do take firms' decarbonization plans into account when they form their beliefs about companies. Well, let me summarize. There's more that we do in the paper, but I just wanted to give you an easy overview. So the summary of what we do is we define this notion of carbon burden, which is just one dimension of a firm's value to society, but we show that it's an important dimension. And our two main results are that carbon burden is big. It's big relative to market value, including debt, if you like. Nonetheless, it's modest relative to the consumer surplus that US companies create. And the asset pricing result is that carbon burden is priced in the cross-section of returns. So market participants seem to pay more attention to future carbon than to past carbon. And that's all I had. So I'm looking forward to your questions if you have any.
Many thanks, Professor Pastor. Really, really, really interesting paper. So we have I have some questions. So I give time to the webinar attendees to formulate their own, if that's okay. So I will start from a couple of questions of mine. So again, really many thanks for the really insightful presentation on a really insightful, really interesting paper. So the first question I will start with is that, I mean, it has to do with how we estimate, how we predict emissions. So essentially, it seems to me there is an assumption that in states of the world with high economic growth, there will be more pollution, more emissions, right?
In the model that the EPA uses to estimate or to forecast aggregate future emissions, then that is the feature of their model. Yeah, it's not present in MSCI's framework at the individual firm level, because MSCI simply takes a firm's own target and then applies a credibility.
They apply credibility weights.
But at the aggregate level, the forecasts of the EPA and the other government agencies do have that feature. So they are forecasting higher emissions growth in states of the world where the economy is stronger.
And then I wonder whether the two approaches check out, whether the firm level approach sort of aggregates nicely to the same figures that we get from the aggregate. And the reason why I'm asking is because there is a literature that shows that sort of essentially that gives us results, empirical results that suggest that sort of the inverse relationship might not be there. So I'm referring, for example, to the work published in the Review of Financial Studies recently by Xu and Kim that shows that distressed firms are the ones that pollute the more. So I would assume that in economic states, that in bad economic states, there will be more distressed firms, so they will pollute more. So that would actually hit the sort of the inverse relationship between economic growth and the positive relationship between economic growth and emission that is posited, in formulating the estimates at the aggregate level. So that's why I'm saying it might actually be interesting to see whether the two approaches check out, right?
So two things. One is you're raising an important question, and I think a key dimension of the answer must be the difference between the time series of the aggregate and the cross section. So cross-sectionally, multiple studies have shown that firms that are more in distress tend to pollute more. Causality there is tricky. But yeah, firms that are more in trouble, if you're a company that's in trouble, you are less likely to invest in a green project. You're fighting for survival, right? So that makes a lot of sense. To what extent that translates into an aggregate time series relation is less clear, right? Because if the economy is weaker, it's not clear that there will be less pollution from carbon. Historically, that has not been the case. Historically, in a weaker economy, people travel less. There's less,
Right.
left
That makes
in
sense.
the air.
Yes.
So, but this goes back to something I talked about near the beginning. We don't know yet. We don't know yet what risk premium we should apply to future carbon forecasts, precisely because of issues like this. We just haven't done enough work as a profession to nail down the risk premium associated with carbon emissions. Let me also answer the second part of your question, which was kind of implied. You asked, to what extent does the MSCI's firm level approach, to what extent is it compatible with the EPA's aggregate approach? And we cannot check it fully because MSCI covers, fewer than 3,000 companies. If I add up
Right.
all of their emissions, I get to maybe half of the total emissions in the US.
Right. So we can't check out. Right.
Because for
Okay.
most companies are not. I mean, the US has many more than 3,000 firms.
Right.
And their emissions are not included, and then government has some emissions, and so the total, the aggregate is not just the sum across companies. That whatever I talked about in the aggregate part is literally for the aggregate economy. Whatever I talked about at the firm level is just the corporate sector.
Many thanks. So there is I add one while we still wait while we wait for a few more questions. I have a sort of another a question and a half. One is the half question is about the social cost of capital. It's sort of a follow on the previous one. In some sense, I'm thinking perhaps in the different states of the world, that sort of the marginal utility or the marginal disutility assigned by society to pollution, right, to emissions differs. What I'm thinking, for example, is in states of the world in which there is greater economic growth, people are better off, and people are more, they will tend to dislike more pollution. Okay, so there's something. So think of the pyramid of needs, right? So in states of the world in which we are better off, we would like to be in a world that is less polluted. So I wonder whether there is a possibility of incorporating that kind of perspective. But while I'm conscious that the data, I mean, essentially the social cost of capital, social cost of carbon estimates come from EPA, so it depends what what they've done with it, what they've done to produce the data. So, but I wonder whether there is a possibility of adding that perspective. So that's one question, and the second, I mean, that's half a question. The other question I would have, and sort of also thinking of some questions that I'm seeing in the Q&A, it's I'm thinking of a spread, right? Okay, I picked up that there is a spread between the carbon burden, bad, and the consumer surplus, good, right? The carbon burden and consumer surplus produced by the corporate sector, right? There is a spread. And if I read the graphs, the plots correctly, it seems that this spread is time varying, right? So I'm wondering whether there is we can see covariation in public attitudes towards emission, covariation between attitudes and the spread. So do people sort of become more or less tolerant towards emissions, or more or less intolerant, depending on this spread?
So let me start with the second question.
And that ties up with some of the research you've done on political cycles. So yeah. That's why I'm asking, because I think it relates to other work you've done.
Yeah, no, it would be very interesting to see what determines people's attitudes towards emissions, and we don't know enough about that. We don't do much on that in the paper. In fact, we don't have a chart of consumer surplus, so I hope I didn't give you the impression that the only thing we have about consumer surplus is one number from Pellegrino's paper, so we don't do anything with consumer surplus. But it would be very interesting to see to what extent, or what are the determinants of people's attitudes toward carbon emissions. Another way to put this is concern about climate change a luxury good, or is it or not, right? Is it that in good times when we can afford to think about this, then we do, and if we're in trouble, then we don't. I actually have a paper from 2020 with Blair Forsatz where we don't find evidence of that. We find that even during COVID, people cared more about sustainability than during other times. So, but we need more research on that topic. And this relates to your first question as well. You asked whether it's possible that during high growth episodes, people are going to dislike emissions more. It's totally possible. I will say that there is an offsetting effect, which is that during high growth periods, people will have more resources, more money to deal with these higher emissions. That they'll be able to do more in terms of adaptation. So that goes back to what I keep saying, which is we need to do more work on trying to figure out what are the good states, what are the bad states of the world, because they're opposing forces whose net effect is unclear. And you've delineated a couple of them. I've delineated some, and they just pull in opposite directions.
Thanks, Professor. Professor Pastor, there is a question in relation to the discrepancies between MSCI data and true cost emissions data, right? Even for disclosing firms.
Right. So I didn't talk about that at all in
right.
my talk, but we do have in the appendix, we talk about discrepancies between true cost data and MSCI emissions data, because we worked with both data sets. Only MSCI has forecasts, but both MSCI and true cost give you estimates give you past emissions.
Give you past emissions. So in theory, you could actually use the true cost emission data and apply the same approach as MSCI to produce your own forecasts, right?
We could, and we actually do some of that. So I only told you about half of the paper, but it's the juicy part of the paper. In the less juicy part of the paper, we run our own regression. We actually, instead of taking MSCI's forecast,
that's what.
We produce our own econometric forecast. We run vector auto regressions. We have a section on that, and you can run those VARs either on true cost data or on MSCI data. And in the appendix, we talk about the discrepancies. In the process, we noticed that there are meaningful discrepancies between those two data sources. Okay. So that's what we talk about. It's a secondary part of this paper.
What would be your view on the discrepancy that that you see in the data? Is it something to be concerned about for the credibility of emissions data? That's the question that comes from the floor, from the audience.
Yeah. So when you talk about credibility of the emissions data, it is crucial that you specify which emissions you're talking about.
Okay.
Scope 1 emissions are the cleanest. They are the direct emissions by companies. They are the most credible. We report the correlations between MSCI and true cost in the paper. They are reasonably high, not perfect. But once you get up to scope 3, anything goes. Because most companies don't report their scope 3. And if they do report scope 3, you don't want to use their scope 3 estimates.
Okay.
Scope 3 has 15 categories. Okay. And virtually no company reports all 15. So companies cherry pick. I'm gonna pick 4 of these 15 categories, the ones that make me look good. And those are the scope, and I'm gonna add them up, and those are the numbers I'm gonna put out. And then financial companies almost never report their scope 3 based on category 15, which is their holdings of other companies. So they exclude those. Now, what MSCI tries to do, they actually have their own model that based on which they forecast scope 3 emissions. Okay, so this is now you're transferring your trust from companies to MSCI, which seems like a reasonable thing to do. So it's tricky. I don't really have much insight into the credibility of these forecasts. Clearly, there's a lot of uncertainty associated with any forecasts of emissions.
Thanks, Professor Pastor. So moving to asset on the asset pricing side, people essentially are asking whether, essentially, it's your feeling is that from the estimates, from the results in the asset pricing part of the paper, whether your feeling is that what's priced is the transition risk associated with the emission, with the scope 1, 2, and 3 emissions, I guess.
Yeah, so what is the source of that asset pricing relation? Why do markets care about future carbon? They seem to care more about future carbon than past carbon. So what I've already mentioned is that market participants seem to give extra credit to companies with more credible or more ambitious decarbonization plans. And so we voice two possible interpretations in the paper. And I don't think we have the data that allow us to figure out which is which. But my favorite explanation is indeed transition risk of the following kind. It's carbon tax risk. So if there ever is a carbon tax so just to be clear, there is no federal carbon tax in the United States. There's a small gas tax, but if there ever is a carbon tax in the future, then companies with larger carbon burdens are going to be hit more, right? Because it's future carbon that is relevant for future carbon tax. Backward-looking carbon is not going to be taxed. So carbon tax risk is the risk that should fall especially on companies with large future carbon as opposed to past carbon. And we've recently added some analytics about this, showing that there's actually a clear mapping from carbon burden divided by market cap to carbon tax risk. You can actually quantify carbon tax risk.
That's Appendix 6, right?
You're ahead of me. It's in the appendix. Yes.
Okay.
I don't know which appendix. I
think it's number 6 now. I'm going by memory.
We added it recently, like maybe a week ago, 2 weeks ago, something like that. So what I'm saying is carbon tax risk can be measured with CB over M, is what we show in the paper. That doesn't mean we don't have proof that it's carbon tax risk, but it's a very plausible story. An alternative is that people have tastes for low carbon firms, and these tastes are stronger for firms with stronger decarbonization plans.
I guess it depends. I mean, that's two views on who imposes the privatization of the social cost, whether it's the government through taxation or whether it's the public through its consumer, consumer choices. And I guess that answers the question. I mean, there is a question that sort of a policy-related question. Someone from the floor in the audience was saying, if the biggest chunk of the emissions come from 30 big emitters, so maybe policies should target them. But I guess you answered the question in some sense. So carbon tax, right? Naturally, it's the biggest.
No, so this is tricky. So our focus is only on the US because we have data on the US. But if you look at global emissions, US emissions have been declining for some time. They continue declining in the future. China produces more than twice US emissions. And there's a growing emissions in China, India, Nigeria, Brazil. I'm naming names, but these are large, fast-growing emerging countries where, when I say fast-growing, I'm talking about population growth. Population growth is just as important as growth in GDP per capita in generating future emissions. I think the only way we can actually tackle the carbon problem globally is by incentivizing those less wealthy countries to adopt green technologies. And how can we do that? Moral suasion is not going to do it. The only way we can do that is if we make those green technologies cheaper. So innovation, R&D, make sure that solar is already cheap. Wind could be cheaper. Grids are not in a good position to store all that intermittent energy coming from solar and wind. So we need to do more innovation on essentially producing grid level large batteries that can store all that. If we make renewable energy cheaper for countries like India, etc., then they will transition. And that's the real global solution in my view. Carbon tax is going to be challenging because companies can move.
Right.
Yeah, Europe is trying this tariff, what do they call it? Carbon border adjustment mechanism.
So is the EU, I believe. Yes, I suppose, yeah.
And maybe it'll work. It has incentivized some countries to change, but you'd have to combine carbon taxes with tariffs. It's the only way you can actually do this. And I don't know that that's necessary. You're not going to get all the players to the table, right? It's not clear you'll get China and Russia and to sign on to the global carbon tax. So I'm a bigger believer in using innovation to make renewables cheaper rather than trying to do a carbon tax is worth trying, but I'm less optimistic that it's going to.
Many thanks, Professor Pastor. I believe this answers several questions that have been asked on the international the international setup and policies that can be implemented at the international level based on the lessons that we learn from your study on US data. So because I'm conscious of your time, to close the webinar here.
So with that, on behalf of Financial Management Association International, thank you all for coming to the seminar. Thank you, Professor Pastore, for kicking off our spring semester series with such an interesting and relevant paper that has such huge implications in terms of climate finance, as well as the global economy as well. I can't think of a better paper to kick us off for the spring semester. So thank you very much.